Today we're going to learn about multiplying polynomials. Let's start with a review of the distributive property. When we distribute, that means we're going to multiply the term on the outside times both of the terms on the inside. So we essentially are doing 6v times 2v plus 6v times 3. Notice that the 6v gets repeated twice because we're distributing. 6v times 2v is 12v squared because we multiply by the coefficients and add the exponents. We bring down the plus, and 6v times 3 is 18v. These are not like terms. There is no equal sign, so we're done here. Would you please try to solve this problem now? You should have distributed 7t times 5t and 7t times negative 2. So you're doing 7t times 5t minus 7t times 2. Again, notice the 7t gets multiplied twice because we're distributing. You should have multiplied 7 times 5 and gotten 35, and t times t, which is t squared. 7 times 2 is 14, and then we just bring down the t. These are not like terms, and there's no equal sign, so we're done. Today we're going to expand that into multiplying binomials and trinomials. So let's start by looking at the area of the rectangle. This box here shows that I have a length of x plus 6, and I'm multiplying times a width of x plus 2. I can multiply this in two ways. I can use the box method, where I take the x and the 6 and split them up, so that I'm doing x times x, which is x squared, 6 times x, which is 6x, 2 times x, which is 2x, and 2 times 6, which is 12. That becomes x squared plus 2x plus 6x plus 12. And then we simplify the like terms, so it's x squared plus 8x plus 12. This is called the box method. You draw a box with the same number of rows and columns as you have terms, and then you multiply the corresponding. So x times 6, 2 times x, and 2 times 6. You will likely more frequently use the distributive property. Notice we now have two things in front of our parentheses. Essentially now we're using the distributive property twice. We're multiplying x times x plus 2. That takes care of that one. But we also have a 6 times x plus 2. Now we're going to distribute. X times x is x squared, not 2x. We're not adding. X times 2 is 2x. 6 times x is 6x. And 6 times 2 is 12. We combine our like terms, so it's x squared plus 8x plus 12. Either of these methods works. This is the one that you will likely end up using more frequently, but if you like the box method, go right ahead and do that. So again, when we multiply binomials, we are using our distributive property twice. We are doing 8p, the first term, times 6p plus 2, but we also need to multiply negative 2 times 6p plus 2. And then we distribute. 8 times 6 is 48, p times p is p squared, 8 times 2 is 16, and we just bring down the p. For this one, we don't want to forget that there's a negative in front of the 2, so that becomes negative 12p minus 4 because we're doing negative 2 times 6p and negative 2 times 2. We combine our like terms, it becomes 48p squared plus 4p minus 4. You tried this problem on your own. You should have written down 6x times 5x minus 8 plus 8 times 5x minus 8, and we distribute. 6 times 5 is 30, x times x is x squared. 6 times negative 8 is negative 48 with the x. 8 times 5 is 40x, and 8 times negative 8 is negative 64. We combine our like terms. We bring down the 30x squared. Negative 48 plus 40 is negative 8x, and that's minus 64 there. Now, sometimes we want to square a binomial. I want you to notice that there is a minus in the middle of this. We have learned before that if I am doing 4x squared, then I can just distribute that 2, and it becomes 4 squared times x squared, so that would be 16x squared. The minus messes that up. I cannot distribute when I have a minus in the middle there with an exponent. It doesn't work that way, because what this means is I am squaring the whole thing. I am doing 4x minus 1 times 4x minus 1. If we distribute, we can see that it becomes 4x times 4x minus 1, minus 1 times 4x minus 1. We did 4x and negative 1 times 4x minus 1. We distribute, so that's 16x squared minus 4x. We do negative 1 times 4x, which is negative 4x. We do negative 1 times negative 1, which is positive 1. We combine our like terms, so that's 16x squared minus 8x plus 1. That is not the same as just squaring each one of these. If I had just distributed this, 4x to the second power becomes 16x squared. The negative 1 times the negative 1 becomes the positive 1, but we have lost that whole middle term. That is not correct. All right, you go ahead and pause the video and try this one on your own. You should have used your distributive property to do 2x times 2x plus 3 plus 3 times 2x plus 3. We distribute the 2x, so it's 4x squared plus 6x. The 3 times the 2x is plus 6x, and 3 times 3 is 9. This becomes 4x squared plus 12x plus 9, and that's our solution. There's no more like terms, there's no equal sign, so we're done there. If we want to multiply by a trinomial, then we need to use that distributive property 3 times. So we're distributing, 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 distributing. So this becomes 8 times 3, which is 24x to the 5th. 8 times 4, which is 32. Don't forget there's an invisible 1 there. 3 plus 1 is 4. And 8 times 7 is 56x to the 3rd. There's no like terms, so we're just done. Go ahead and try this one on your own. This becomes 2 times 1, which is 2. And then there's an invisible 1 there, so x to the first times x to the second becomes x to the 3rd. 2 times 2 is 4x, and 2 times negative 3 is negative 6. Oops, I have an error here. Can you find it? This should have been an invisible 1 as well. So when I did x times x, that should have given me x squared. That is our solution. Now, sometimes we'll be asked to perform some arithmetic on polynomial expressions. So what they're telling me is I have this function c equal to x plus 6. I don't know what c is, but it's equal to this thing. And I have d equal to 3x minus 6 plus 4x squared. So I don't know what d is, but it's equal to that thing. It's telling me to find c plus 3d. What that's saying is, use your order of operations, multiply 3 times whatever d is. That's what we're going to start with. So we're going to do 3 times 3x minus 6 plus 4x squared, because this whole thing here is what d was. We distribute, just like we did in the previous slide. 3 times 3x is 9x. 3 times negative 6 is negative 18. 3 times 4 is 12, and that's 12x squared. Now we're not done. We have done we have done 3 times d, but now we need to add c. So this goes back to adding polynomial expressions. Remember, we can only add like terms. So far I have 9x minus 18 plus 12x squared, and I need to add on c, which is x plus 6. Now I can combine my like terms. 9x and 1x make 10x, so those are gone. Negative 18 and 6 make negative 12, so those are gone. And the 12x squares has no like terms, and so you bring that down. You can rearrange this into standard form if you want. 12x squared plus 10x minus 12. You pause the video and try this one on your own. All right, so we have b equal to 2s plus s squared and a equal to 3 minus 4s squared. They want me to add b to 3 times a. So the first thing I'm going to do is 3 times a. So that becomes 3 times 3 minus 4s squared. I'm going to distribute. That becomes 9 minus 12s squared. So that takes care of the 3 times a. Now I need to add the b. b is 2s plus s squared, and I need to combine my like terms. There was an invisible 1 there. Negative 12 plus 1 is negative 11s squared plus 2s, and then that's a positive 9, so I bring that down. And we're done. There are no more like terms, and there is no equal sign. So in your summary today, you want to remember that to multiply polynomials, we use the distributive property. Make sure you finish this video all the way through so that it submits, and have a great day.